Okay, so in this tutorial, we are going to learn to do some image processing using Python. And there are different libraries that you can use in Python to do some image processing. One of them is called PIL or PIL. And so basically, this is the library that we are going to use. And I have decided to do a tutorial on this library because we are going to use it in several other projects. So it will be helpful as a reference. So basically, you will have this notebook, and I will provide you some of those pictures that I have uploaded to my Google Colab environment. And basically, the idea is to try to understand a little bit the functioning of this library using Python. So the first thing, PIL is already installed in Google Colab. So all you really need to do is to import it. And in particular, we are going to import some module from the PIL library, and one of them is called image. So let's click on this. And imagine that you want to work with a specific image, this one here. Okay, so let's, if I double click on that, the image would open here. Okay, but let's try to see how to have it open in our notebook per se. So what you need to do with this module image, you need to use a function open, and you pass as argument to that function the name of the image that you want to use. And basically, by doing that, you are creating an object, which I call, it's a name, EMG, and that image, that object EMG now includes, if you want, this picture of the dog. Okay, so and if you want to display it on the screen, all what you need to do is to type EMG here, or you could say display EMG. Okay, you could do this, or you could, and then you don't need that, or you can simply do that. So let's do it. And you see you have an image of a dog. Okay, and we may want to know what are the dimensions of that image. And basically, if I ask to print the size, well, I can ask as well to print the format of that object called EMG and the size of that object. And so what we are going to see is that it's a JPEG file, which makes sense. That was a JPG extension. And we see that actually the dimension of the image is 980 by 147, 1470 actually. And basically, what does that mean? It means that you have actually 960 pixels in that direction and 1470 pixels along the y-axis. And of course, you have pixels inside the picture as well, so that actually you have actually 1470 times 980 pixels in that pictures. So pixels are, little dots of color that, the first one is here, the second one is here, the third one is here, etc. And you have actually 960 pixels along that very first row, and then 960 pixels along the second rows, up to the moment when you reach the last row of the of the image. What is a bit confusing with the PIL library is that actually, well, the X axis goes in the traditional direction. So as you go in that direction, the X values increase from 0 to 1 and eventually to 980. But the y-axis goes in that direction here. So you go from zero to 1 and eventually to 1,470. Now let's suppose that you want to crop a detail from this picture here. Let's suppose that you say, well, no, I'm only interested with this part of the picture. Okay, how should you do that? Well, basically, it's simple. Okay, you on the EMG object, the image object that you have created before, you simply use a function, the function crop, and you say exactly, how you want to crop the picture. So the 0, 0 here, it's truly this. You want to start from, the edge, the upper left edge of the picture. So this one here, that's what the argument says. And then you want to go 700 pixels toward the right. So you take 700 pixels along this axis. And then you take, I think, 500 pixels along that axis. Okay, that's the 500 that you see here. And then you can assign this to a new object or a new variable that I call, it's arbitrary, em underscore crop. And then if I want to see on my notebook the results, I simply have to repeat the name of that variable. Okay, if I do that, here is what I'm getting. So that's this new object or that variable, which is clearly this thing here. Okay, so we have crop 700 pixel in that direction and 500 pixel in that direction, starting from the top left of the image, 0, 0. Of course, if you can crop different segments of the pictures. Here I have cropped only 500 pixels along the x-axis and 700 pixels along the y-axis. And if I redo that, that's the image I'm getting. I had the image before because I run my notebook just before recording this lesson. Now, of course, you don't need to necessarily to put those numbers here. You can simply assign those values to variables, like here. Left is equal to 155, top is equal to 65, right is equal to 360, bottom is equal to 270. And write this like that: left, top, right, bottom. So, I'm gonna take from, so the left top means that, I don't start from 0, 0. I start from a value for x equal to 155, and the value for y is equal to 65. So I want to start somewhere, I'm not sure exactly, somewhere like here. Okay, and then the last two numbers, tell me how much I want to go in that direction and how much I want to go in that direction. So that's what you see here. Left top, right bottom, how much I want to go in the right direction and how much I want to go in the south direction of the picture. So if I do that, same principle as before, run this and I'm getting this image. Okay, of course, I can rotate the image, the initial image. So, if I apply to the object, which is basically this initial pictures, if I apply a function asking to rotate this image, I can have it rotated by 45 degrees counterclockwise. Okay, and if I want to have it rotated 180 degrees, I would put 180 here. Okay, and well, I can. No, it's like Photoshop. Huh? You can apply all type of filter that you want. If you want to introduce some filter, you need to import not only the image module, but the image filter module that I have called here. And then from that module, we still need to import some specific filters. So you see blur, fine edges, smooth, sharpen, etc. And like once I do that, then you can try different filters. Like, I start again, I say, well, we are creating an image object from this file. And then we basically apply a filter on the specific filter that I have used, fine underscore edges. This is passed as an argument to the function filter. If I run this, I'm gonna get a new image, and you can see the impact of that filters. Okay, and of course you can do different other things, like there is a filter called emboss, and I can run it for you. And so you can see what it does, and you can try by yourself. Okay, here a filter called contour. It's a bit like a sketch that you would do from the pictures, actually. And try by yourself. Okay, replace specific filters like those names that you see here: enhance, detail, blur, in place of fine edges, for example, and try to see what it gives you. Here we can always add to the original pictures. We can always add some text. Sometimes it's called watermarking. And so again, in order to do that, I need to import two new modules. One is called image draw, and another one is called image font. And so once I have imported all the modules that I need, I can again create my variable here. It's an object, as it is called in Python, which includes, or which has saved, if you want, the initial pictures that we have. And we'll also ask again the size of the pictures, but we already know the size, so we didn't really need those two lines here. And let's suppose that we want to write some text on the original pictures. And I'm going to show you the final product. It will be something like that. This is a Dalmatian. It's the name of the dog. And basically, in order to do that, I need to use the module image draw. The dot draw here tells me that I'm using a specific function that will create a new object called draw. And that object will be used in order to draw something on the original image or on this object EMG that I have created previously. I want to add some text. On the text, you see text to add. That's a name that I gave to that variable. And the text is, this is a Dalmatian. So this is, so text to add is a variable that takes this value. This is a Dalmatian. Also, well, you know, text can be written with different font. You know it, Courier or Roman, Times Roman. In Google Colab, you have several fonts that you can use. One of them is called Humor Sans TTF. And you know, this is the font size 20, okay? So the bigger this number, the bigger the letters. You basically, this line here simply says, well, you know, this text, I want this text to be font written with this font and with this font size, okay? And also, you know, I have to indicate exactly where I want this text to be located on the picture. So I put, remember the corner is 0, 0. So I have put 10, 10, okay, which is, you know, the top left of the red inscription, the T here that you see top left is a 10, 10. That's what that means. And then, you know, this function here, okay, I'm gonna use it. This object, I'm gonna use it to apply the text. So text, if you want, is a function, is a method that we are applying to that object draw. And we want this text, this is a dimension, to be added at location XY using the font that we mentioned previously. And after that, I can simply say, well, show me the results of that image. So the draw function will superpose on the initial image some text given by this expression. And this expression has been explained point by point above. Okay, so what is X and Y? What is the text to add? This is this thing here. And what is the font? The font is basically this expression here. So if I run this, I'm gonna get this image, okay? Of course, you know, you can change, okay? You can, if you want, you know, the principle of watermarking is to provide an inscription, but so that it's not totally obvious, okay? So you can play with the color of the text in order to make it less obvious. Like you could choose a color that could be green instead of red, okay? You can see that I have put red here, but you know, you could put green. And later on, we are going to see what are the channels of a pixel, okay? So I'm gonna talk about this a bit later on. So anyway, we have created this watermarking. And then we can save this new object, EMG, where we have basically introduced the text. We can save it and give it a specific name, dog6 watermark.jpg. And if I do that, somewhere here you are going to have a new image, which is basically the one that we have created. Now you can download that into your computer, or you can double click on this thing and you are going to see that's the image with the watermark that we just created. Okay, so this tutorial is a bit long, so I'm gonna stop the first part of this tutorial now and come back with a second video.